Okay, using everything I've taught you up to this point, we can now add the numbers 1 to 100. But before we do that, I just want to start with something simpler and add the numbers 1 to 3. If we can add 1 to 3, then we can change the 3 to 100 or 1,000 or whatever we want to do, and we'll have it correct. But let's just, that's kind of a debugging trick I like to do up front, is just start with something small that my brain can handle. Now, to do this addition, we're going to need two registers. We're going to need one to store the sum, all right, the running sum. So initially we'll add 1 to it, and then we'll add 2 to it, and then we'll add 3 to it. All right, that is called the running sum, or the accumulation. Okay, we are going to accumulate all these values. A good register to store the accumulation would be the EAX register, because A stands for accumulation. Alright, so EAX will store the accumulation, or sum, if you would. And then what would be a good register to have count go 1, 2, 3? Or if we're doing 100, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What register would be good for that? Well, ECX will store the count. Right? Notice there's a big C there. The C stands for count in the register ECX. Now, yes, EAX, EBX, ECX, and EDX are general purpose. Use them for what you want to. But the letters A, B, C, and D have special meaning and do special things in certain locations. It just so happens that A stands for accumulation. It is the most general purpose of all registers, and we are going to store the accumulation there. And C stands for count. And there's some special assembly instructions we can use that maybe I'll show in a different video to have it count. But for now, I'm just going to say we'll count here, we'll add here. All right, so first thing I want to do is move into EAX the value 0. Let's 0 it out, and then move into ECX the first number we are going to add, which is a 1. All right, well, let's put our little looping label right here. I'll say again. And down here I want to say, well, add, let me bring that up a little bit, add to EAX the value that is in ECX. Alright, so that will add the 1. Alright, now we want to increment ECX. So after we do the increment, we need to do a compare. We need to say, hey, is ECX up to our upper bound here? Well, what is our upper bound? It's 3. So compare ECX to 3. Right, as we've seen in previous videos, all this does is set up those flags in the flags register. And then at what point do we want to jump? We want to jump as long as we are less than or equal to. Right? As long as we're less than or equal to 3, yeah, jump to again. Right? Jump less than or equal to again. Otherwise, it won't jump and we'll return and go back to C++ land. Right? Does that make sense? We do the compare against our upper bound. Right? If we're less than or equal to, then we go and we add the value that we're currently at. Then we increment again and compare. All right, so let's just watch this. F11, Control-Alt-D, F11. All right, 0 EAX out. Let's take EAX out to a 0. Put the 1 in ECX. There we go. There's our 1. Let's add to EAX the value that is in ECX. And I'm going to draw a C up here for ECX. All right, so EAX, 0 plus 1 should give us a 1 right there. So let me F11 on that. And sure enough, there's our 1. Okay. Increment ECX. So we're done with the 1 here. Sorry, we're done with the 1 here. Let's take ECX up to 2. Alright. So increment ECX. Here we go. That'll be a 2. Compare ECX to 3. Well, that's going to do the subtraction. 2 minus 3 will give us a negative value, which means that we're less than. So jump less than or equal to. Notice here, this indicates a negative value. You can review those videos if necessary on the flags register. Jump less than or equal to this memory address, or this location in code, which is right here. So go up there. We need the 2. We're going to add it to our sum. So 2 plus 1 gives us a 3, like so. So we have now added the 1 plus 2, and that's given us a 3. That is what is in the EAX register. Increment ECX, we're done with that too. Let's take the ECX register up to a 3. So here we go. ECX will change to a 3. F11. Sure enough, it is a 3. Compare ECX to a 3. Well, that's going to be 3 minus 3 will give us a 0. All right, and you can remember from the previous videos, the 4 here indicates that the 0 bit is turned on, the sign bit is turned off. All right, so no, it is not less than, but it is certainly equal to. So we will jump to this memory location again in code. So there we go. We're going to add the 3. Right, add this 3 that is in the ECX register to the 3 which is in the EAX register, like so. We hit F11. Watch this value here change to a 6. Then I think we're done with all this. Our result is 6, and that's nice. Okay, there's our big fat answer. Increment ECX, that will take it up to a 4, which is past our upper bound. All right, we do the compare, so it'll be 4 minus 3. The sign bit will not be turned on, neither will the 0 bit be turned on. It's not a negative value, and it's not equal to, so there you go. Jump less than or equal to, well, it's not less than, it's not equal to, it's greater than, so then we will fall through to the return, and 1 plus 2 plus 3 plus nothing else is a 6. Okay, very nice. We've taught the computer, we've programmed the computer to add up the numbers 1 to 3. Well, what if I want to add 1 to 100? Well, hopefully that's pretty straightforward. Shift F5 to stop the debugger. Control Tab to go back to our code file here, and I'm just going to change this to 100. Pretty simple. F11, Control Alt D, F11, and sure enough, 0, 1, add, 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 add. You can see this number growing, and yes, it's in hex, but still, we're going all the way up to 100, and I'm going to have to press F11 a whole bunch of times, and that will get exhausting and tiring, so I don't want to do that. So another thing I can do is set a breakpoint. The breakpoint says, hey debugger, just run the code until you hit this point in code. All right, now where do I want to put the breakpoint? Well, I just want to let this loop run. You see the yellow arrow, how it goes, and it goes. Our loop is right here. All right, run, 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 run. I wanted to run all these instructions until it's done, at which point it will fall through to this instruction right here, our return instruction. So there's a few ways to set a breakpoint. The simplest probably is to just go into this gray area of the window and click. That will set a breakpoint, and then I will hit F5, which means computer, go until you hit this point. Watch how fast the computer can add. I'm going to hit F5, 1, 2, 3, F5. There we go. And 1 plus 2 plus 3 plus 4 plus 5 is this number, or plus all the way up to 100 is this number in hex. Now what is that number in decimal? Something maybe we're a little more familiar with. Again, we can use the calculator to solve that problem. So view, programmer, switch to hex mode. Let's just type 13 B A, and in decimal we can see that's 5050. Alright, anyway, there you go. There's breakpoints, there's looping and counting. I'm going to click here to get rid of the breakpoint. Shift F5, stop the debugger. I'm actually going to go back to our code and let's see how long does it take to add 10,000. Alright, let's F11 that. Control Alt D, F11, F11, put the breakpoint back on the return, hit F5, and there you go. That's as fast as my computer, while recording a video at the same time, can add. It's the blink of an eye. The best way I can describe it is a computer is a really fast idiot. Alright, if you think about it, there's not really much intelligence going on here. The computer is not thinking for us by any means. It's just following these instructions as we gave those to the computer. However, it is extremely fast at doing it. So hopefully you're starting to see the power of knowing how to program. If I can have tell the computer exactly what I want it to do, and it can do it extremely fast, then I can get really cool effects like animations or games or calculations or anything I want to compute. So there you go.